Hello everyone, who found it doing great. Welcome to Elyas Tech channel. If you're new here, welcome, and I'm so happy to see you all once again. Of course, today I have a special guest, my friend. This guy is a lot of information, spending, I believe so, more than 20 years of his life only doing research about a lot of things. I didn't want to introduce this guy. I will allow Mr. Mateen to introduce himself. Mr. Mateen, first of all, hello, how are you?
Hi, yes, I'm doing well. Thank you for bringing me to this interview. It's a very pleasure to be here with you today.
Thank you, Mr. Mateen. I'm speechless. Mr. Mateen, please, who are you and where you come from?
Thank you. My name is Mateen Hoshang. Of course, I was born in Afghanistan. I'm very happy to be in this podcast today. And by profession, I'm a data analyst. I've been in the field of data science for like almost 6 years now. My academic background is in statistics and economics, where I have a associate's degree in social science, a master's in political science, and a master's in economics and development, and that's where I am. But thank you for all the good compliments. I just wanted to pass my disclaimer before the conversation starts that I would love for this conversation to be in one of the Afghan languages, either Dari or Pashto. But for the sake of your audience and to make this interview benefitable to your wider view audience. So we're decided we're not having this conversation in English. So.
Oh, appreciate it. Thank you. Yeah, I do respect our native language as well, as you said. But of course, since I do have an audience, they just want to listen in English. That will be nice to speak in English with you.
I'm very happy to do that.
You say that you have an academic background in social science and economic and are currently working in a field of data analytic. How did you ensure a successful transition from the field of social science and economic into the data analytic? How did it work? Explain to us.
Thank you. That's a great question. When I started my academic journey, I had in mind to kind of go toward the directions of social sciences, of sociology, where I can get to learn about human behavior as a whole, and that relationship with our kind of natural science, right? So that's the pathway I started right after high school, and of course the social science route falls under the art disciplines in a lot of ways, depending on how you look at it from a epistemological perspective. So and also I was inspired by my family to be able to work in the fields of humanitarian services, or at least in the long term be able to author my own books or any advanced academic research involving human subjects. But at some point in my academic journey or during my university time, I realized that the way we look at the social phenomenon or the social elements, overall academic perspectives are broken down into two parts. There is the qualitative way of looking at things, and there are quantitative ways of looking at things. So as I got exposed more to a like objective, quantitative a view of life subjects or social phenomena, I realized that we can make good use of data and statistics or quantitative studies and analyses to be able to study and establish knowledge of humans. So as an undergrad student, that's when I was more introduced and got involved in numerical research or numerical studies, where we apply scientific methods to produce knowledge of human-related subjects. So it's such a delicate pathway, but with that idea, I think any undergraduate or a graduate school a student is able to transition into data field as long as they're able to understand and have a good fundamental grasp of how to apply data and numerics and quantums into social subjects. So the way I transition, my transition actually started way before my undergrad, where as a teenager, I remember I would spend a lot of time looking at data models and structure and architecture, and a lot of things started to make sense to me. And I started asking questions. How does a data field talk to, let's say, a model? How does a query happen within those very basic tools that we learned as we were growing up, such as Excel and Access, and then it later developed into Visual Basics, right? So, but those are only the start of the data lifecycle. And the data analytics comes kind of toward the end of that whole data lifecycle. So I already had the fundamentals, and I think any student, any person who has used Excel or who have taken algebra classes and understands mathematics and statistics can easily transition into the data analytic, more like basic data analytic profession. But then as time goes, as they experience different practices in the field, they will be able to transition into more advanced data analytic and pathway toward data science. So that's where my journey took place, where I used my academic research methodologies, quantitative ways of computation and calculations, and also something that I'm sure having graduated from school in the field of computer science, there's something called hypothesis, right? Or hypothesis test. So when you are testing hypotheses, it doesn't matter that hypothesis in the context of a social subject, or if it's in the context of a objects oriented subject, you will be using certain statistical models in order to establish those hypotheses. And that's a huge breakthrough to allow you to transition into the realm of data analytics and data science. And again, the most important thing is your ambition as a person. As we believe, if you have ambition for something, if you're hungry and thirsty towards, it doesn't matter what it is,
True.
you will always attain it. If it's knowledge, and of course, you'll always be blessed to attain it. So a combination of all of these traits and characteristics have actually helped me to get to where I am.
All right, Mr. Mateen, you have mentioned to me on a personal occasion that you have developed a concept of knowledge spectrum. Could you explain this to us, and what are the logical foundations?
So this is something that I've brainstormed. I wouldn't credit myself for having developed this logic, spectrum logic of how education disciplines could be distributed within this spectrum. But simply, this spectrum goes from the left to right, where on the left of the spectrum we have all of these art-related educations, or in other words, knowledges that are produced from your way of thinking, from your ideas. For instance, if it's a belief or something that you believe in, that falls under that umbrella of spectrum. That's the left spectrum. And the right spectrum is, the spectrum of science and natural science, or a tangible science. And for science to be defined, established as science, it has to be tangible. It has to be reproducible. It has to be testable. So on the right spectrum of this knowledge discipline are all of these science-related epistemologies that can be produced and reproduced and put to test. And this spectrum, we have science and data science and computer science and machine learning algorithms and medical science, but anything related to the physics and experiments are on the right spectrum. And of course, we sometimes use the word knowledge interchangeably. We say, okay, this person is very knowledgeable, or this person has knowledge of this. If we break this this understanding down into these minutia of left and right, then we have to specify if that knowledge is product is a mere product of thinking, which comes from this left spectrum of knowledge building, or if it's a product of a scientific knowledge where it was produced and tested and verified by scientists. So that was the spectrum of knowledge.
All right. So you meant like right and left is right is more theory and left is more theory and right is more practical. That's what you mean?
Well, I
It's
wouldn't
all
say
imagination, come to the reality, and you
yes,
have to.
yes. Theories is something that becomes first before knowledge is produced.
Okay.
Theory is like the first hypothesis or the first supposition before a knowledge is actually put into investigation. So I would say theories in both of them, even in the left spectrum. Let's say let's say in the field of literature, there are theories related to literature. There are theories related to history. But these are not. There are two types of theory. There are theories that could be that are data tested or data backed theories or scientific theories, and then there are theories that are purely ideological theories that cannot be tested, that cannot be verified. So of course, but to answer your question, yes, the right spectrum involved more theories and then testing those theories to see if they are really valid.
All right, Mr. Mateen, you have mentioned about the statistic. How is it applied to the natural science?
Yes. So let's consider the analogy of a vehicle and gas. So a
Vehicle and gas.
vehicle and a vehicle is pretty much the data, and the gas that makes the engine in that car in that vehicle running is the statistics. So statistics is one of the most important characterization of data, especially any data that involves numbers or non-text data, as you know. And the way statistics works is that I know a lot of definitions describe statistics as a branch of mathematics. Depending on who looks at it academically, it's correct to define a statistic as a branch of mathematics. But I think a statistics, I personally believe that statistics is more a science itself alone. It's an independent science where statistics has some powerful models that it has inherited, developed, and have been built upon over the centuries, that today we're able to make good use of the statistics for our daily, not only for data analysis, but also for logical reasoning and for inferential reasonings. And so, especially in the context of philosophy and the context of conceptual reasoning, we can never deny or outlaw the role of the statistics, because statistics is the building block that allows quantum calculation or logical quantum reasoning and philosophical questions, let alone data analytics. So of course, I had the reason I'm interested in this particular question is because my journey of data analytics, where I am, actually started from statistics. And so statistics is something a lot of people misunderstand, is that they think statistics is like 1 plus 2 or like algebra. It has borrowed some
Principle.
rules and theories from algebra, but statistics again statistics is helps do what beyond algebra can achieve. And as an undergrad student, I remember having done researches involving let's say voting behaviors, involving socioeconomic indicators in a society given a demographic, right? So I use statistical models to be able to actually draw an inference from those samples of data that we have in order to produce a knowledge that is generalizable. Because here's how it works, Elyas. It doesn't matter how much resources you have, especially in the field of data analysis using samples. It doesn't matter how much resources you have. It's almost impossible to go and survey all of your population. So what countries in the world they do is they use statistics. So the way they do it is they gather samples,
Hmm.
and then they use statistical models to infer, meaning to make a claim about the general population using those samples. So it's one of the most essential roles in data analytics where you perform descriptive inferential statistical analysis to actually draw a conclusion from the sample. Not only that, but also test theories and hypotheses to
Hmm.
check either that the understanding that we get from the sample is something that we can infer about the general population, and then use that to predict future behaviors within that study. So, of course, statistics is, again, one of the most important building blocks in the field of data science and data analytics. And even like we cannot deny the important role of statistics in today's machine learning algorithms. A lot of algorithms are using statistics and statistics linearity regression models in order to produce those knowledges, algorithmic knowledge.
Where do you see the art discipline of the statistic?
Yes, thank you. That's actually a great question. We can't deny, as we just talked about this, we can't deny the important role of data and statistics and data science and the field in the realm of science and natural science. And what I mean by natural science is medical science and all the sciences that are
Correct.
experimental and testable, right? So of course we make the scientists, the professionals and academicians, they make great use of them. But in the field of or in the discipline of arts, which I explained earlier, where we have all of these educational disciplines that are product of narratives and ideas and thoughts and beliefs. I would say that right now, and I actually that's a good question that you asked me how you see the future of it, because it's still debatable if data or quantitative way of looking or studying these art-based educations are actually effective or actually productive. The reason why is that, and again, by discipline of art, we mean anything that involves human subjects or anything that's product of beliefs and thoughts. So the reason that question is being right now circulated in academic discourse, and there's a lot of journals and literatures out there that have actually evaluated the efficacy of quantitative approaches in these fields. And so they are, those who are already in the field, they're claiming that, data analysis or statistical analysis is a good way to actually explore what has happened that we don't have the information for, or even like to be able to explore human behaviors, but it's still being debated in both professional and academic realm. Now, let me give you an example, Elyas. Let's say if we are to apply data in the field of human behavior or human psychology, right?
Mm-hmm.
And I'm there with my notebook and I'm writing notes about how you behave every morning, right? And I observe you that you wake up every morning at 10 a.m. and you, let's say, do something regularly at 10 a.m. every day. And I see that this is happening on a regular basis. And then based on that observation, I turn that observation into a data, and then I apply a model to it, and I say, okay, and then I see more samples like you, right? And let's say I would say people between the years of 20 and 30, 31 or 32, however old you are, and then apply this knowledge to the whole world of youth to say that all youth, when they wake up at 10 a.m., the first thing they do is whatever you did, whatever that I established that you will do. Now there's the counter thesis or the counter debate in this type of approach is that human behavior is not predictable. Human behavior is not is dynamic.
Thank you.
It's not concrete. It's not something that you can actually see something happening on a regular basis and it will remain the same. And because of this dynamic and changing nature of our behavior, it's very difficult to actually establish a scientific study on it. right?
Makes sense.
Although when we deal with blood or pathology, or let's say samples that are produced by us, those may be living things by nature, but they don't have human type of behavior. So we look at the characteristics of those things. Either it's blood sample, or either it's scientific or computer related information. Those are not dynamic in the way that human behavior are. So maybe in the 11th day, all of a sudden you decide to do something else. Now your behavior is actually changed. And with my level of confidence that I bring into the study, to say that no, because I observed Elyas and 20 or 100 other youth doing the same thing, like this observe this particular behavior in this generation or in this population, then there's likely that we would observe the same behavior in youth of 20 to 33 years of range in another demographic area. That's impossible. So that's one of the counter pieces that's being discussed in the academic discourses, because it doesn't matter. Whatever you see today that we are putting to use, either it's cybersecurity or computer science or data science or medical science, they all start from research. They all start from academic investigations. So the academic studies actually lead to the phases where we decide either this is something that we can put to use, right, and produce a tangible result from it. So it's used professionally. Data and statistics are used professionally to actually look at the art-related disciplines, meaning to knowledge of thoughts and beliefs. They are used to some extent, but it's not as prevalent, it's not as outstanding and significant as the natural sciences are. But still, if we are able to do some description or some sort of basic study on something that happened in the past, and if you have the data for, of course, it's by no means we can go ahead and do it. But if it involves more advanced in the studies for us to determine a prediction or to give a confidence level to that study, then it's still being debated. It's still being debated that, can we really use data? Can we really quantify whatever that's product of belief and whatever that's a product of a human behavior? So that still needs to be answered. That's something that still people are debating.
The only challenge so far, I think it's gonna be a challenge forever, is to know a person properly. It is very challenge. As you said, we are dynamic, and as you said, human are adaptable. So if you throw them in any situation, you can find and they form themselves and they can start living. All right, Mr. Mateen. So far you have done a lot of research about this specific field of, let's say, statistic, and you grab some information from too many authors and scientists, researcher, or so on. So I just want to listen, and or my audience is waiting for your perspective. What is your point of view so far, based on what you have done and based on your research?
Thank you. That's a great question. I have been involved in numerous researches. A lot of my research focused on economics and socioeconomic related subjects, meaning societal relationship with economics relation, the relationship societal phenomena with economic phenomena indicators. So and because I involved economics, which it's a quasi scientific discipline, right? And economics is considered to be a scientific educational discipline rather than an art discipline. So in my researches, I've been able to come up with solid analysis and results to claim or to reject a null hypothesis of certain nature related to something that was already established. So I can say that when it involves economics, I can say that I support the implication or application of scientific approaches, in which case we're talking about statistics. And I did have many researches where I was able to again to apply these scientific ways. For example, one of my research involved poverty, right? Poverty, the three indicators of poverty, distribution of land, and violence, structural violence. So all of these could be quantified. So, for example, a distribution of land, we can quantify it. For example, how many acres of land does a family have? And let's say the other variable, we call it in data terminology, the word is variable. So the one variable was the distribution of land. The other variable was structural violence, right? Mm-hmm. Structural violence had most like subjective, nature. That was one of my control variables here. And the other one was poverty. Poverty has a lot of objective indicators such as GDP, income, savings. You can name it. So poverty can be measured. That's what I'm trying to say. So I have made great use of scientific or data-driven approaches in my studies, and I was able to produce knowledge using these experimental designs and experimental studies. But when it comes to, again, I'm going to shift back to what I was saying earlier. When it comes to human behavior, especially human behavior that relates to like personal behaviors. It's if it does not, if it's because again, since human behavior is very abstract, it's very subjective. It's not, we can objectify it. We can try our best to objectify certain behavior, but it's not permanent. So having been involved a lot in like socio-psychological human behavior research and tests. But I personally believe that statistics and application of data has its limit. It's at the limit. Even when you open any statistics book, you would read in the preface that says statistics is a good breakthrough to the knowledge making process, but using statistics has to be very careful, because if you make a mistake, or if you use the statistics for a wrong knowledge or for a wrong context, then you're producing invalid knowledge. So therefore, I would say, as someone who's been in the field, that applying data or a statistical study has its own context. We can borrow some statistical, some data-driven study approaches in our human behavior analysis studies, but it has to be limited, because and then it takes us to other approaches, which I don't think we have time to discuss those in more like qualitative, observational or ethnography or other type of studies where it involves the researcher to actually observe and to study the context of a subject rather than just simply writing data notes. Does that make sense? So if you're studying, let's say if you're studying a culture, let's say you're studying a culture of XYZ in XYZ country. So in order to fully understand the culture, you can put numbers in their behavior, but numbers will not give you knowledge. That number will not contribute to a valid knowledge building process. But if you go in there and you spend time with this community and you observe their behavior and you talk to them and you ask them questions and you see how they behave to certain their situational behavior, then you will be able to actually produce more an informed knowledge of what's happened rather than simply just relying on numbers and data. Does that make sense?
Really makes sense. All right, Mr. Mateen, let's talk about the professional terminologies used for the data-related field and rules. Some of the most outstanding titles that I can think of are data scientist, data analyst, business analytical professional, and business analyst. What are the differences?
Thank you. That's a great question. Professionally, first of all, Elyas, this whole data profession is very new in the market and it's very appealing to a lot of people, and a lot of people are studying it. And to be honest with you, I've been in academic realm for like the past 9 years. When 9 years I started my academic journey, I was thinking about kind of getting on this pathway, trust me, there was no major in universities called data science or data analytics.
Mm,
There were some majors
interesting.
close to it, such as engineering that could lead to it, or like business information systems that could lead to data analytics, right? Because it's again data analyst profession is very comprehensive, and it borrows these professional disciplines from all sorts or walks of professional roles. For example, as a data analyst, you need to have like certain, and we can come up to this details later. But as a data analyst, you have to be a good communicator. You have to have understanding of computer sciences, computer information systems. How do they work? You need to be able to you need to have good understanding of statistics and algebra. To do like basic arithmetic calculations. So you have a combination of different skills and expertise in order to become a data analyst. So that's why the universities did not have a specific major called data analyst or data scientist. They had these close majors that aligned with the profession, but they did not have a degree or an academic major called it by these names. So today, a lot of people they ask me this question that, okay, what is the difference between data analyst and data scientist and business analyst? These are pretty much professions that have commonalities
Mm-hmm.
to a good extent. The roles and the responsibility overlap between these roles and responsibilities. I'm going to start with data analyst. Data analyst is someone who actually collects information and analyzes them and produce knowledge out of them. So
Mm-hmm.
in simple words, someone who analyzes or decodes data. Simple as that. Either it's quantitative, numerical data, or text data, or whatever data is, JSON, image, whatever. Now, data science, on the other hand, is like a little bit advanced. So data scientist is a person who actually goes beyond data analyst,
Mm-hmm.
who actually does not only rely on human data sources. And as a data analyst, you would probably collect your information from a survey or from some Excel spreadsheet or a data set. But on a data scientist, their approach or their extraction of their access to information goes beyond working with human sources. They actually work with computer sources. They work with algorithms. They create these input and output machine learning algorithms that allows the model to actually work with the data on a real time basis and bring the data as an input and bring and then output the data, and then based on that create knowledge, create information,
Mm-hmm.
right? Streamline the whole process. That's where the data science. And then we have business analytics professional, who is someone who works in the field of business, uh, kind of uses a lot of expertise and skills from a data analyst role, but applies that to a business context. So as a data analyst who works in the field of business is a business data analyst or a business analytics professional, where again, someone a business analytics professional produces key performance indicators, creates charts, creates trend lines, how the business is doing, what does the operation look like, what is the functionality environment in the business, and how we can improve it, how to optimize and streamline the processes in the business. So that's the business. And the last one is business analyst, and I'm happy that and I'm talking about this last one because the last one is highly mistaken for business analyst professional. A business analyst is someone who works more in the software defined life cycle or software development environments, where this person is collecting information from the clients or from the actual stakeholders, and then translate those requirements, those information into something tangible, to technical terms and specification, to be able to produce a sort of document, a sort of knowledge that could be relayed to the developers, so developers could produce an application or tool or product. So and then relay the same information back to stakeholders. So a business analyst is someone who is in between an IT environment and a non-IT environment to be able to translate, to transform understanding between both of these stakeholders.
And I really appreciate the way you explain each question with more details. It does require the arts as well. You have mentioned about arts, but you have a good art of communication as well. Reality
Thank you
check.
so much.
Yeah.
I personally believe, and sorry for interrupting, I personally believe that when it comes to data analysis or anything that involves analysis, even if it involves like pure scientific analysis, the start point has to be artistic approach. A scientist has to be an artist. I think a good driver needs to be a good artist. And by artist, I don't mean particularly someone who can paint an art, but what I mean by that is someone who holds these special traits and characteristics of inquisitiveness, curiosity, critical thinking skills, and the ability to be able to look at to have a multifaceted paradigm or a multifaceted perspective into something that person looks at. That's why I always say the art of science.
What are the most important tangible and intangible skills that a data analyst should possess?
Thank you. That's a great question, actually. That's why at the beginning I said that anybody could be a data analyst as long as that person has the ability to think critically and to be curious about a piece of information that's given to them. If I give you a piece of document and you see some information, a piece of document that creates question in your mind, that moment you dive into a process of data analysis.
Okay.
Maybe it's not as structured and advanced as it should be. I know it's not scripting language, but you have embarked on a journey on a path of analytical study of something. The moment that you start asking questions, the moment that you show curiosity, the moment that you use logical reasoning and logical manipulation into a given stimuli, then you are actually entering the realm of analysis. Either it's data analysis, information analysis, whatever analysis you can look at. So I would say that anybody could be a data analyst. If I could become a data analyst, definitely anybody can become a data analyst. And for you to become a data analyst, it's very important again to start with working on these. I know you mentioned tangible, intangible skills. Intangibly, I would say, the ability to adapt, ability to adopt, ability to be inquisitive, to be curious. And so that would allow you to actually start on a path to lead to analysis. And then, of course, a good data analyst should have good communication skills because, you are using, and before I talk about communication, there's a very famous quote from, I think it's either Newton or a different thinker who said that a good analyst is the person who spends 90% of the time 90% of the time analyzing the information and 10% of the time solving the problem.
Albert Einstein.
There you go. I read it a long time ago. I couldn't remember exactly who this thinker philosopher was. So if you are that kind of person, and if you find yourself, spending a lot of time thinking through, a given piece of information, then you're there. So about the tangible skills, I was talking about communication, right? So communication is very important because once you decode information from analysis, you should be able to convey that information. So the ability to communicate both verbally and writing is very important for you to succeed as a data analyst. And of course, talking about tangible skills, it's important for you also to learn some technical skills, and that's almost less than half, around maybe a quarter. If I were to break down the skills of a data analyst, I would break them down into 4 parts. It would be the first, number one, the most important one is what I just explained to you: this natural skills of inquisition. The second one is the communication. The third one is the ability to analyze, or ability to look at to use technical expertise. Use the technical expertise to be able to produce knowledge. And then the fourth one is to be a good, and that kind of falls under the communication umbrella, is for you to be to have context or contextual information. For example, let's say you're a data analyst and you're going to work in the field in the domain of, let's say, medical science or in the health field. If you don't have contextual information, if you don't have information about the health domain, how will you be able to analyze the data? So before you even get to the data analytic part, there's a lot of information gathering. There's a lot of study that need to do that will prepare you to there. And that's a very important part of the tangible skills.
Thank you. As you said, it really makes sense. The curiosity, the passion, definitely help a person to become a good data analytic on the future. Because as you said, if you give me a task, if I don't have any interest, if I don't have any passion, and I would do it like because it's a good income, it's a good salary, and end of the day I may start complaining because it's not within me, it's not an art with me, I don't have a passion, I don't want to go so far with that kind of a specific field. As you said,
Well,
yes, please.
I would always tell my classmates in the past, when speaking of on the subject of passion, we would say there's obligation, then there's passion. Sometimes you follow your passion, but then you follow your passion into something that does not produce much for you, but then there are things that you really want, that you should really have, but you don't have passion about it. That's an obligation. So like you said, when you turn a necessity into a passion, and when you combine these two together, when you know that whatever you're doing or studying, that end result that you're trying to achieve is going to have beautiful fruits, outcome, and then you bring passion into it and you combine them, then you'll be perfect. Otherwise, I think one complements the other. If you have passion, but if you're not on the right route, you may be able to achieve your passion, but then at some point you find yourself alienated from what you ideally thought you would achieve. Or let's say something that you really want to do because you need, let's say, a high paying job, but you don't have passion about it. So one day you graduate, or you evolve to become where you want it to be, ideally to get this materialistic gain, right? But then you find yourself alienated because you ask yourself the question like, is this really something that I want to do? Because I'm here, I'm producing good income, but I'm not passionate about it. So it's always good to keep it balanced. Or if you can combine it, that's even more perfect.
All right, Mr. Mateen, you have mentioned about the data analytic, data scientists, and so on. I think it's time to ask which kind of tools, which kind of application we're using in order to accomplish these kind of, I know these are huge goals, but so let's say for a fundamental, for people who just want to start their career in a data analytic, which kind of tools they really need to know as a person just putting their steps in this field?
Thank you, Mr. Elyas. That's actually a great question, because as I myself am actively on YouTube, and I sometimes produce educational videos, and I also review other educational videos where, unfortunately, a lot of presentation or demonstration on data analytics only focuses on tools and technology. I kind of reiterate to what I was saying earlier, that those are important, and I'm going to answer this question only after I tell you what I'm about to tell you. Before any student, anyone, I don't know if any of your audience can hear me, before you start to learn to code or use these advanced, sophisticated analytics scripting languages, you need to learn the fundamentals of statistics and data. Otherwise, you're going to be spending a lot of time learning how to write and understand the syntax, but don't understand what are the fundamentals of those. With that being said, I suggest that someone who would like to get in the field of data analytics, they should start by reading a book, Principles of Statistics or Fundamentals of Data, to understand what are the foundations of data before even getting to there. So, and then once they're ready with that, the first tool of choice that I recommend is Excel.
Excel.
I know Excel, a lot of people
Microsoft Excel.
use Microsoft Excel for producing worksheets and metrics, stuff like that.
Mm-hmm.
But recently, with the recent releases and modifications that Microsoft have had on Excel, they've actually built a lot of built-in function as well as a lot of add-ons. That's add-ons are like those supplemental packages that come with Excel that that they can make use of, that have basic to advanced data and statistical analysis features. The good thing about Excel is that Excel is easy to use. Although I know some people, when they look at the metrics and cells, they become so scared, like, oh, that's something we don't want to. That's the route we don't want to go to. But then once you start to learn the triangulation and the arrays of rows and columns, it will start to make sense. So before diving into like Python and R and all these highly
Scripting language.
sophisticated and highly difficult to learn languages, start with Excel. Start to do like very basic arithmetic and statistics studies using, let's say averages, standard deviation. You need to know what the distributions are, and to what the normality distribution are, those kind of stuff, basic statistic models. And once you learn Excel, that's the good foundation for you to move on to other programming languages. So maybe you can learn Excel and SPSS. That's an IBM product. I don't know if you ever heard the name SPSS and Stata. SPSS and Stata are used a lot in the academic fields, especially for PhD students and master students, because again, doesn't matter what discipline of education you study, you would always be needing to do some sort of quantitative research, and that will require you to use Excel or one of these advanced drop-down menu software languages such as SPSS and Stata. So although professionally, Elyas, it's SPSS is kind of outdated. A lot of employers, they don't need it anymore. A lot of, if you read through the job description of data analyst, data scientist jobs, it's mostly scripting languages. They do mention Excel, but it's most of the time there's no mentioning of SPSS or Stata. Again, because these two are used more in the academic realm. So again, once you learned one of these three, if you can learn all three of them, that's perfect. Then I would say start with R. R is an open language. It actually allows you, it's actually free. And it also has a lot of packages, and it's continuously built. You can make great use of those packages to be able to solve your problems. And something else about R and about all languages is that it's almost impossible to remember the codes, the scripts. It's important to understand the script. It's important to read the syntax of the script. Just like the language learning, and this is the most important advice I can give to people who wants to learn language and coding. Before you learn a language, either it's coding language or a vocal language, like a language, you should learn the syntax of that language, not even semantics. There are two compartments to a language. There's the syntax and there's the semantics. Syntax is the parts of speech, the building blocks, how you produce sentences, how you put words together to make sense, how you put tenses together. And the semantics is the meaning. You can learn to say a bottle, you can learn to say a pen, but if you don't know how to say you need a pen, then it doesn't really help. So if you say pen and someone hears you, what do you really mean by pen? Do you want to buy a pen? Do you want to give me a pen? Do you want to receive a pen? So syntax is very important. In any language that you're trying to learn, it's very important to learn the syntax of the language. What are the parts of the language? How do those parts come together to make a sense? So to learn R, and again, any language, it's very, very important that you understand the syntax. You have to be able to read and understand the syntax. And once you are able to understand the syntax of the script, then you don't have to write the script. You can actually borrow, or you can just copy from other scripts that are written out there and just bring it to the model. And so R, again, after those three I mentioned, R, of course, Python is very important. SAS, also another language called SQL. That's a query language. A lot of times you would find yourself extracting information for data analysis. SQL is not used so much for data analysis as much as used for extraction of the data, especially when you're working with servers and we are looking with huge volume of data. Excel can only view 1 million records at a time and one sheet. So if you're dealing with multiple, with multi-million records, then SQL is the language, and you use query language to extract those SQL, CSV, or whatever output you want from SQL and embed it onto your programming languages. And lastly, data for data science purpose, the use if you're working on becoming a data scientist, once you take care of all the fundamentals, which I just mentioned at the beginning of the video, which was statistics and foundations, then I would suggest to learn Python, because Python is such a huge and widely used language. You can also use Python for machine learning algorithms, and that provides a pathway for you to become a programmer, not only in the data field, but also in like object-oriented software application, and etc.
During your earlier conversation, you have mentioned about the algorithm. So, do you have any information about what is algorithm and where the algorithm come from?
Yes, that's actually interesting. When this conversation of data starts with people, I can't wait to give them this information, because it sounds like a lot of people don't know. Today, machine learning algorithms is embedded within all the tools that we use. And an algorithm is pretty much a system or a model where it receives information and creates a model and then outputs that model. If you're using your GPS application, that's an algorithm-based platform. If you're using your Netflix, that those suggestions that you see on your Netflix view list, those suggestions that you see on your YouTube view list, all of those are pure product of an algorithmic chain of logic that's embedded onto that tool. Speaking of the history of algorithm, and that's the reason I said you saw that smile on my face the minute you start talking about algorithm, right? So the word algorithm actually derives from the word Al-Khwarizmi, and so the person actually invented Ibn Sina and all these great philosophers and scientists. They were not only like people who invented these mathematical and logics. They were also like what we call them. They were like polymaths, and polymath means somebody who has knowledge of a variety of disciplines. So these people were polyglot, meaning they spoke multiple languages. These people were mathematicians. These people were philosophers. These people were poets. These people were like owner of wisdom and literature. So imagine, and then these are people that actually opened one of the initial scientific discourses on medical science. So, of course, that's the history, behind the word, the concept of algorithm coming from the word Al-Khwarizm. Although, we have to also give credit to the civilization. And Al-Khwarizm used to live, invented the idea of algorithm around 9th century CE. That's almost like 1100 before, prior to today. So we did have people before Al-Khwarizm, like Euclides or Aristotle, and even from the old Chinese civilization, who actually did this idea of numbers. We did actually have kind of engage in the production of knowledge in numbers and in quantums. So we would give them credit too. So, but, theirs were only limited to more like, calculation and counts. But Al-Khwarizm introduced a breakthrough of algorithm chain that, although it wasn't on computer systems, it was on a canvas, right? Where the mathematical logic were used. And today what we see is the footprint, or what we see today marks the initiative that he took back in the day. So that question was an interesting one for me because of the geological word algorithm. So
Yeah, thank you. As I said, guys, this guy is a lot of information. Last question that the people can find you. You said you have a YouTube channel, and I will definitely put the down description your channel as well, so they can find you and follow you, and to your YouTube as well. So what else? Just YouTube, and is there any other places that people can find you? Walkways. How about
Yes.
walkways?
What was that word? Walk race?
How about in the walkways? I mean, and
Well, I spent a lot of time working and also studying and doing research. I'm hoping that I will get on a pathway for my PhD in economics. My plan is to, my plan is to improve on my econometrics. That's my specialty, econometrics, which is the metric of economics or mathematics of economics. That's what it pretty much means when you quantify economic related indicators. Pretty much any economic development that you see around the world, like GDP, GNI, and GNP, all these global economic crises happen. That's kind of my area of concentration academically, and also in the future, that's what I'm planning to do. Hopefully, get on a PhD program to research and expand my expertise and the skills there. And again, I would like to. This is what I meant earlier when I said I would like to expand our academic activities to, not only, I know data analytics is just something that your viewers can watch and make use of for professional purposes, but and we may have additional podcasts where we can discuss and share knowledge of things that may be of importance to non-technical audience, such as sociology, philosophy. We can share those kind of knowledge with your audience.
really appreciate it for your time and being available and accept my invitation to be a part of the tree that I just built through the YouTube.
Thank you so much. The honor is all mine. The pleasure is all mine. Thank you for inviting me over, and I really, really hope that I was able to deliver something to you and your audience today.
All right. Thank you, Mr. Nateem, once again.